Okay, so our topic for today is measurement of temperature with thermocouple. So what is thermocouple? Thermocouple is an electrical device. It's an electrical device is basically an active transducer. It's an active transducer which is made up of two metals which are joined together. So when two metals are joined together, there will be something called a junction where both metal touches each other. And when you put this junction in a temperature sensing environment or higher temperature, an electric potential will be developed, which is measured by a voltmeter. Because how can you measure voltage, electric potential? By a voltmeter. What actually happens is both of the metals have different work function, and whenever you put that junction containing both the metal in a temperature difference, where in an environment where there is a temperature difference, a voltage will develop because the difference of work function causes electrons to flow, but the electron flow is accelerated by the external temperature being sensed. So thermocouple is the most widely used temperature sensor. Remember, there are three: RTD, thermistor, and thermocouple. But thermocouple is best. So what if other systems are used? There are others. We will come to that. For now, we will focus on thermocouple. Thermocouple is the best one, widely accepted, and is very its response is very fast. Another important fact is it's cheap, and they can be interchanged. Like they can, if you don't get one thermocouple, you can change to another thermocouple without affecting the system that much. Since thermocouple don't require external power, the system will be very effective. We don't need any external powers. But remember one more thing: the output voltage is very low. So even though they don't produce, they don't require external supply, but we do need amplifiers. Amplifiers are required to amplify the weak voltage at the output of this thermocouple. Another main limitation, remember this, there is a limitation. We have so many benefits, but one big limitation, like error cannot be controlled. A system error or measurement error less than 1 degree centigrade is very difficult to achieve. Thermocouple at least will produce an error of 1 degree centigrade. This line says so. Produce an error of 1 degree centigrade at least. They are generally used in high temperature measurement. What are some applications? Like high temperature or temperature measurement in gas turbine, diesel engine, and many industrial processes. Thermocouple is also used in home in a device called thermostat, flame sensor. Okay. Now thermostat and flame sensor. Thermostat is used in fridge, AC, to regulate temperature, and gas sensor or flame sensor to sense fire. Recently, I've been seeing some kitchen utensils which are employed with flame sensors. Even in aircrafts, cars, there are flame sensors which will immediately start the fire extinguisher system if it senses that there is a fire there. This is the standard thermocouple arrangement. This is the standard thermocouple arrangement, where this one is the area. We have two metals. One is alumel, another is chromel. So alumel and chromel are two different material, and there is a junction where actual junction where the sensing is done. That is where the both material or the both metal are joined. We will expose that junction to the sense environment to be sensed. We will expose the junction to the environment which is sensed, and it will give some voltage output, but that voltage output cannot be directly converted to temperature. For that we need another, which is a reference temperature. So your voltage output will vary depending on reference temperature and sensing temperature. Reference temperature, this must be fixed. You must know the value of temperature, and it must be very controllable. Don't use a reference temperature source that whose temperature keeps on varying. So reference junction or the reference temperature junction is very, very important. The accuracy of this junction will determine the accuracy with which your sensing environment temperature is being sensed. So you have two temperature sources. One you are measuring, that is unknown, and one is known. Now this thermocouple, like the chromel and alumel, both are exposed to both the temperature, and then copper wires. These are wires which connect the thermocouple to your voltmeter. Now I have written, you have seen here it's written T meter, not voltmeter. Why? Because once you get the reading at voltmeter, then you have to subtract some reference voltage value, and then what you have to do is look up a table which contains this V minus Vref value versus temperature, and you get your temperature output. That's one way. However, we'll see that it is little bit different, but this is the basic technique. Now, as we have seen here, not only the accuracy with which the temperature is sensed, but this reference junction temperature is very important. If you don't know it, then you cannot measure your temperature using thermocouple. So reference junction temperature must be known. It must be known before you start measuring. There are two techniques. One is ice bath method, and another one is reference junction sensor or pole junction compensator. In ice bath method, this part, this part is immersed or dipped in ice, frozen ice or semi-frozen ice. So the reference temperature becomes 0 degrees centigrade. And now you can measure the temperature and then you get your output. So you have to subtract 0 degrees centigrade out of it. Reference junction, cold junction compensation. In this part, this is a new technique where you have a reference junction. That is, this part is mounted or placed near your in sense environment, but here another sensor is kept, which measures the temperature at this location. It's like a semiconductor thermometer, or in some cases they use RTDs. Like in one of the cases we'll discuss, they will expose this junction to 28.4 degrees centigrade using a standard RTD. That's PT1000. So whatever you get, the voltage you get here, you find the corresponding temperature, then subtract 28.4 degrees centigrade, you get your actual temperature in degrees centigrade. So there are two techniques. One is reference junction sensor and the one is cold junction sensor. Now we'll come to the type of thermocouples which are found commercially, or you go to the shop, you'll find them. The first one is this one, braided wire. It is a type of thermocouple which are like two wires. The two wires are in a jacket, okay, and there is an exposed point which are where there is a thermocouple alloy added. But the problem is they get easily oxidized and they can corrode, but they are not generally used for temperature sensing. They are good for sensing, like measurement for gas temperature, where you have to ensure that your junctions won't get corroded. They are very small and they can provide a good response time. Actually, every thermocouple provide a good response time. Then comes the probe, the standard one. If you go to the shop, like or online on Amazon, you will get this one. It's cheap. It's very good. There is a metallic tube. The metallic tube, you will have some. There is a probe on the sheath, like this part. This part, the top part, there will be an opening where the probe will come out. So basically, this area, the top part, is very important for sensing. These are widely available and these are generally used for high temperature measurement. And you can find three types of tips: grounded, ungrounded, and exposed. Grounded means this metal body is grounded, connected to the negative supply, so you don't get an electric shock. Ungrounded means they're left floating, nothing is connected, so there is a chance you may get shock. And the third is exposed. The tip may be kept open in the air, which may create a lot of problems, ground loop problem. The exposed junction is good for measuring where you have measuring air temperature, where you don't have to keep the device in contact with something. Third is surface probe. Surface probe means these things have a attachment. Like you can put something here, you can connect it to something here and tighten it. There is a solid surface, and that part is your exposed thermocouple. Once that part is connected, like once these things are attached perfectly, the thermocouple will keep on sensing and it will carry the energy through the wire that way. The fourth is wireless thermocouple. These are actually not limited to just wireless thermocouple, but it can be a part of anything. These are brought about by a new term called IoT. IoT, industrial IoT, made this a requirement, where you can measure temperature remotely. You don't have to stay close to the industry. You may even stay in some other country or state. The device, the thermocouple, will stay connected, and that thermocouple will be connected to a wireless transmitter or an internet relay circuit. The whole data will be relayed to the internet, and remotely you can download it from your mobile phone or computer. These are some of the thermocouples. The best one is nickel chromal and nickel aluminium. The nickel chromal is suitable for high temperature measurement. Similarly, nitrocell, that's a different one. Their sensitivities are also given here, so you can see and remember. Chromal constantan is a very generic one used for, which has a measurement upper limit of 900 degrees centigrade. And constantan, as we have learned in theory, also is a negative material for most of the transducer. This one is the circuit diagram for thermocouple setup. That's a Maxim semiconductor IC. This IC will do all the signal processing, analog digital conversion, and everything. What we have here, the thermocouple is here. We will discuss a little bit about this one, a little bit more about this one. Thermocouple is here. The thermocouple is connected to two input pins of the IC. One is the reference pin, another one is not reference pin, it's AIN 1, analog input 1 and analog input 2. How this thing work? This work by subtracting the voltage received in AIN 1 and AIN 2, or analog input 1 and analog input 2. So this makes the arrangement differential, like op amp. This makes the arrangement differential. So what are the benefit of being differential? That there is no common mode error. So all the errors due to noise or any imbalance are subtracted. But what else do we need? We need, as in every thermocouple, we will need two things. One, the environment to be sensed, and second one is a reference temperature. So how we will connect this one? The K-type, remember K-type thermocouple is a standard thermocouple. So this part is where temperature is sensed. And there will be a second part, like here, you will have to give a cold junction. Cold junction means you have to give, say, a bath of ice there. But here a bath of ice is not used, and RTD is used to measure the temperature there. That is the reference temperature technique. And RTD established this cold junction to be 28.4 degrees centigrade. So you will get some voltage value, and you know that RTD is giving 28.4, and finally this will be given at the output. See, sorry, 24.8. The RTD establishes a cold junction of 24.8, and you get a voltage value. So once you have know this, and you know this, the software here will use both of this reading to give you the accurate temperature in degree centigrade. Now how the software makes a reading? You got two input voltage, you know the temperature, cold junction temperature, and from the two input voltage you calculate V thermocouple as VAIN1 minus VAIN2. That is difference between the two voltages. So say for instance you got the voltage reading as 0.0881 volt, this difference. So how will you convert it? You will convert it like this. You will look this table up. All the voltage and their equivalent temperature are here. You will look this table up. 0.0881, that falls between this. That means your temperature is between 0 to 25 degree centigrade. So 0 to 25 degree centigrade, say 0.0881. Let us write this as 0.1 only, 0.1 volt. So if here you see at 0 degree centigrade, your voltage is 0. At 25 degree centigrade, your voltage is 1.407 volt. So how much is 0.1 volt? So what we got is, for 1 degree rise in centigrade, we can assume that volt per degree centigrade between 0 to 25 degrees centigrade. And now if we multiply 0.1, we can get our temperature approximately how much. Let's try to calculate. Let's see, 0.1 into 1.407 divided by 25. Oh, sorry. We are calculating temperature. So it should be, for 1 degree centigrade, the voltage should change by 1.407 by 25. So that is 1.407 divided by 25. 0.05 volt for 1 degree. But here the change is 0.1 volt. So how many degree it will be? This much. 0.1 divided by 0.05. That is 2 degrees centigrade. Now this reading will almost be, let's say this is 0.1 volt. Sorry, this will be 0.1 volt. This is 2 degrees centigrade. But the actual temperature will now be this plus the 2 degrees centigrade, because that was the cold junction temperature. So this will now be 26.80 degrees centigrade. That's the temperature that the thermometer, or the thermocouple is sensing. What else is here? This IC also requires something else. This is how the thermocouple is connected. The RTD is connected for establishing. Just 1 minute. So what were we? Okay. We have a differential input. We have like any other IC, we will also require standard voltage references. Why? Because there is an analog digital converter. Every analog digital converter require a precise and like precise reference voltage source. This Maxim IC is a precise reference voltage source. Once it establishes a precise source, the internal analog digital converter will do the conversion and the subtraction, and ultimately it will provide the digital output. This is actually a serial digital out signal, which will go to your computer or other microprocessor for processing. But this IC also has a benefit. As I said before in the start, that the thermocouple output is very small. So this one has a variable gain or programmable gain amplifier, PGA. It's called programmable gain amplifier. Just hold 1 minute, I have a call. Oh. So you need a programmable gain amplifier. Why? You need to control the output voltage. You need to control the gain. Why? Because already the thermocouple input is very low and you want sufficient output and you want it as you wish, like the gain should be under your control. So for that reason, you need a programmable gain amplifier. A fixed gain amplifier will always provide a fixed output voltage, but a programmable gain amplifier will provide a variable output voltage. So finally you have the D out, which is sampled by your computer, and then through a Maxim software you can display it. And that's it for today. These are the 10 questions. Send me the answer by next week, everyone. Any question you have?
No, sir. Yes, sir.
Okay.
Sir,
বলো শান্ত।
প্রত্যেক উইকেই ল্যাব থাকবে?
প্রত্যেক উইকে ল্যাব থাকবে। কেন?
মানে একটা করে মানে ল্যাব কপি ক্রিয়েট করতে হবে?
একটা করে ল্যাব কপি ক্রিয়েট করতে হবে। হ্যাঁ, যত তাড়াতাড়ি ল্যাবটা শেষ করে দেবে তত তাড়াতাড়ি you will be free from this one, so you can focus more on your subjects. Okay, any question regarding this one? Thermocouple and all? I assume there is no question. তোমরা সবাই বুঝেছো? So I'll stop this recording for now.